Hello and welcome to this brief introduction to Four Forces Investigator. This is a program I wrote many years ago. Recently done some more work to update it a little bit, but it's quite fun to play with, so I'll just go through some of the basic features and maybe you'll enjoy playing with it too. So the basic idea here is it's a two-dimensional flight simulator. So we have an aircraft flying along here and its flight is being simulated quite accurately. So we have the four basic forces here. We have the black lines basically showing the lift going up, weight going down, drag going backwards, and you can't quite see it in this view, but there's a green thrust line going forwards, and the motion of the aircraft is all simulated based on those four forces. Now the pitch is fixed in this version of the software. So just to simplify things, the pitch of the aircraft relative to the horizon is fixed. So as it climbs and descends or speeds up and slows down, the pitch stays the same, which isn't realistically how a real aircraft would fly, but you can imagine it's got maybe an autopilot on board, which is in some sort of pitch hold mode, and then we can follow along how things would behave if that were the case. I should say it's very easy to install. It's just a single executable file. There's no big installation. If you want to try and download it, you just need to download the exe file, put it on your machine, run it. If you don't like it, you can just delete it. No hassles. Download links in the description, of course. Once you get into this, you can just start flying along here. The aircraft starts off at about 3,000 feet and flying along quite happily. You can see at the moment we've got it going about 100 knots. Climbing slightly, and 1G because we're nice and straight and level. The power's set to sort of roughly a sort of cruise setting. We've got pitch and power sliders over here on the right hand side. And up on the top left here we've got some indications of current sort of flight data. So we've got the coefficient of lift is currently 0.21 based on the current angle of attack, which is 2.39 degrees. And we've got two drag figures here. So we've got an induced drag figure. CD0 is the induced form drag, I should say. It's the current form drag based on the simple shape of the aircraft pushing through the air, and the induced drag, the drag which is inevitably a result of generating lift, is currently very low, 0.01, because we've got quite a low angle of attack. If I reduce the power down to nothing, we'll see first of all, you can see here there's a red line is the resultant force on the aircraft, which is now pointing backwards. So we're slowing down, rapidly slowing down through 75 knots. The angle of attack is rapidly increasing. Coefficient of lift is increasing because we're starting to drop and we've got an increased effective angle of attack. Angle of attack is rapidly increasing here. When it gets to about 12 degrees, we're going to stall. You'll see quite a sharp stall coming up any second. And there it goes, we're stalled. So the amount of lift being produced is now significantly less than it was pre-stall. I only really need to get the nose down. We can see now we've got a resultant force. The lift is increasing, the overall resultant force is increasing, pulling up and to the right. Speed's increasing, angle of attack's coming down, and suddenly we're unstalled. And now we've got back to a nice low angle of attack, but we're rapidly heading towards the ground, so we need to pull up. 2.G pull up there, 2.4 Gs. Head back up. Let's add some power. Green line there shows you your power, your engine thrust, and we'll get it back onto a roughly even keel. So back at 80 knots, where speed's increasing, we're climbing, and the angle of attack is coming down, which is always a good sign. That indicates that as we're increasing our speed, angle of attack's decreasing, and we're quite happily away from the stall. So you can spend ages playing with this, or at least I do. You can play around, try different pitch and power settings, try and do loops and stalls, see how slow you can get it to fly straight and level. Apart from just playing with the pitch and power sliders here, you can also go into the aircraft menu here. You can stop the simulation. So the simulation stopped. The aircraft isn't moving anymore, but we can still play with the pitch and power to change the aircraft's pitch and see for a given, what is now a given fixed velocity and position in the sky, if we could just instantaneously suddenly change the pitch of the aircraft, what would happen? So we can see in this case, if we were to suddenly pitch 90 degrees nose up, with the blue velocity vector still heading off to the right here, we can see we've suddenly got a huge force to the left here and a very strong result, and we're going to slow down very rapidly. If I unpause the simulation now, probably in real life the wings would come off. In the simulation we're going to get a very sudden deceleration from 100 knots down to a much lower speed, and it's going to start falling almost straight down. It will actually fly backwards quite happily if you get into a bit of a mess like this. And we've hit the ground and we're going to take off again. Got full power set, speeds up to 100 knots, so we're flying again. Obviously the ground collision mode is not particularly realistic. So other things we can do in the aircraft menu, if we open up this dialog, we can select some extra information to be added to the sort of diagrammatic visualization here. So we can show the parallelograms between various pairs of forces, which gives us this slightly confusing looking diagram here. Perhaps just want to do one of those at a time. Let's just have the lift versus thrust parallelogram showing. So this just shows how the resultant between lift and thrust is currently being calculated. So at this point, so you can see the lift is by far the greater force, but thrust is also coming forwards here, the green line. And the resultant of those two is mostly a force straight up, but also forwards, which is what's overcoming the drag and keeping the thing flying. There's also work in the pause mode, of course, so you can play around, see what kind of forces you could generate if you were to do something a bit crazy. And we can turn these off. So there's lots more that could be done with these. So I'm interested in comments from anyone that's interested in playing with this. Let me know your thoughts in the comments below, or just drop me an email, and I'd love to hear what you think of it.